So north to south, so that's kind of going in the south direction, right? So 90 degrees to the right would be whoop, that way. So the water would be blowing to the west. So that actually means the water's blowing sorry, water. The water is flowing offshore, right? 'Cause west is away from the shoreline in California. And this actually kind of does something cool. This causes coastal upwelling. So you can see it in this top image here. Typically, it happens in the summertime. The wind will blow from the north to the south. And again, Ekman transport, the water goes 90 degrees to the right. So it's moving offshore. And as this water's moving offshore, it has to be replaced with something, right? The water just doesn't keep moving away from the shoreline and like suddenly the beach is like 50 miles away, right? It's as it's moving away, it gets filled, that space gets filled by deep water. So deep water kind of gets pulled up behind. So this water, the surface is moving this way. The deep water is getting pulled up behind it. And so this deep water is upwelling, right? It's moving from the deep to the surface. And the opposite actually happens during the winter. You get downwelling where the wind is now blowing to the north. And so Ekman transport is towards the shore. And so it actually creates downwelling instead. We're going to focus on the upwelling because upwelling does some really important things here in California. So this water that's being upwelled, right? It's from the depths. It's this water from the depths. So as we talked about, it's low in oxygen, right? Because there's been away from photosynthesis and lots of respiration. So it's low in oxygen. It's cold, right? Because it's from the deep sea, and deep sea is cold, but also it is high in nutrients. It's got a lot of nutrients. And that's one of the main reasons we have kelp forests here in California, because kelp loves cold, high nutrient water. You need a lot of nutrients to grow algae as big as kelp. So this high nutrient water is what allows us to have these gorgeous kelp forests here in California. So that's one of the reasons our upwelling is so important. Next, it says Ekman Transport also creates what we call ocean gyres. I'm not going to go into detail on how these are created, but you should just know that gyres are these big rotating masses of water that kind of fill up whole ocean basins. So big rotating kind of circle of water. And it kind of is showing that here with these arrows. So this would be like the North Pacific Gyre. This would be the South Pacific Gyre. This would be the North Atlantic Gyre. This would be the South Atlantic Gyre. This would be like the Indian Ocean Gyre. So because of Ekman transport and the direction of the wind, you end up with these big rotating water masses. And this is what forms our prevailing currents, are these big rotating water masses. So for example, if we look at the North Atlantic Gyre, we can see you get currents kind of going to the north past the east coast of the United States. And then you have these other currents that are going south past the kind of shorelines of Spain and northern Africa here. So you get, again, this rotating mass of water. And here in the Pacific, you get water flowing this way, you get water going up here, and then flowing to the south past California. That's actually called the California Current. You also get this little teeny, like mini, kind of not quite a gyre up here in the with the Alaskan Current as well. So this is what forms some of our prevailing currents. Again, these are at like a large spatial scale. At a smaller spatial scale, you can get other movement of water, but this is like the large spatial scale movement. So I want you to take a look at this image here and notice, do you see warm water currents, which are colored red, on the east or west side of the basins? So we're not talking about the continents, we're talking about the ocean basins. Do you see the warm water currents on the east side of the west side? And why are those where warm currents are? Why are those currents warm? So take a look at this image and see if you can figure it out.